Hello friends, I will explain the further angular measurements with the help of sine bar. First we'll see the sine principle, how we can measure with the sine bar with this principle. The sine principle is just the ratio of the length of two sides of right angle in deriving and deriving to given angle. As you can see in figure, the sine bar, how it's a rollers. There are two rollers placed at the end, and this is the bar of same height at both sides, that is from the center of this roll, that is H as mentioned. Sine bars are used to measure the angles accurately or for locating any work to a given angle within those closed limits. These are made up of high carbon, high chromium, corrosion resistant steel. Of course, wear resistance is also very high for all these type of steels. That's why one of the reasons. Roller surfaces finish use up to 0.2 micrometer RA used. Grade A accurate. In this there are two grades. Grade A is accurate up to 0.01 millimeters per meter of length, total length. Grade B accurate up to 0.02 millimeters per meter of the length. Now, how we can use the application or uses of the sine bar, measuring known angles or locating any work to a given angle. As you can see, the arrangement is like here. We are putting here slip gauges for a particular height. When the height of this individual slip gauge is known, we can add this and have the total height together. Here is the working angle which is included, theta, and we can measure with the same sine principle as it is named sine bar. Sine theta is being included, h divided by this total length, that is distance between these two, O1 and this particular point A. L is the distance between center of rollers. So with that particular, we can calculate the particular height or even the angle. Now another aspect of this sine bar is we can put directly underneath one of the rollers these particular slip gauges of definite heights, where we can put the workpiece on the top of the sine bar, and with the help of dial gauge we can have the correction, that is straightness, or particularly we can see the surface finish also indirectly is maintained or not, or the particular if there are some angular portions are provided, if because dial gauge is going to change the particular reading at particular position, that can be pointed out. Here the particular things like clamping of the workpiece is very important, that has to be provided correctly. And this sine bar is also, of course, has to be kept all the time on a surface plate, which is a defined surface for this. Checking unknown angle is also possible, that the component on the top of the component, this slide bar is placed other way around, and in this case there are two dial gauges at sides of both, and the dial gauge is the stylus of the dial gauge is kept on this particular top point. Here also it is kept on the top point, and the distance with this vernier height gauge. This is one of the applications where we can put the dial gauge directly at the top and see that particularly checking unknown angle of the heavy component using this particular sine bar. So the angle included particularly for the surface can be measured with the help of reference line. Now what are the limitations? Actually small components can be produced with this, but these measurements are limited. Measurement is limited up to 45 degrees, and from the figure only you can find it out. From loss of accuracy the point of view, in this particular inherently become increasingly impractical and inaccurate as the angle exceeds more than 45 degrees. That means physically clumsy to hold the position, and there are slight errors of the sine bar which may ultimately cause the total angular errors. When the height of that particular individual sine bar is not correct, then total length and height also will change. If in the surrounding the temperatures are changing, that may also find the coefficient of linear expansion theta, whatever is there, is going to change that particular length of a particular slip gauge. So maintained temperature is required or air conditioning. The size of the gauges, instruments or parts the sine bar can inspect the limited size, which is not designed to support large or heavy jobs. So big jobs or irregular profiles or intrinsic shapes cannot be actually checked for these angles with the sine bar. Sine centers are one of the new extension of the sine bar, where on the top there are two centers, where in that particularly you can also put one job or actually hold the job in between these two centers, and with the help of dial gauge, again the inclination angle is limited for this also 60 degrees. particularly inspection of the conical objects are done with this particular science center. This also, along with the slip gauges which are added here with particular height and this inclined angle, this conical work can be placed, and also other measurements which are required to be done can be also done on this particular type of slip gauge. Now the rest part of the particular angle gauges, which are normally defined by particular surface, which will be explained later on by my colleague.